Hello students, good morning. Today we are going to see the continuation for the 11th lesson, that is fundamentals of organic chemistry. So for the topic is continuation of this previous video, that is structural representation of this organic compound. So what are the structural representation? That is 4 types of structural representation. First one is Lewis structure, second one is dash structure, and third one is condensed structure, that is bond line representation structure. These are the structure of the organic compound. How to draw this structure? First one is, what is the molecular formula? C3H8O. So what is the dash line structure? How to draw this dash line structure? Here that is 3 carbon. How to draw? 1, 2, 3. Okay, 3 carbon, then 1 oxygen. So remaining hydrogen. So each carbon having the 4 valency, right? So here each carbon 1, 2, 3, that is 3 hydrogen. Here 2 carbon, here 1 hydrogen, here 1 hydrogen, here 1 hydrogen, this is 1 hydrogen. So remaining 7 hydrogens are the remaining hydrogen. So okay, what is the structure? That is called as alcohol. That is, what is alcohol? That is propanol. What is the structure name is called as propanol. Propanol, that is N-propanol. What is mean by N-propanol? That is straight chain. So N represent is the straight chain of this compound. So that is, it is called as N-propanol. So here that is what is mean by condensed structure. Condensed structure, you can write, you combine this, that is CH3. Okay, first you write CH3, then CH2, then CH2, then OH. Okay, this is the condensed structure. So what is mean by bond line structure? What is bond line structure? That is in your carbon, that is CH3 means that is one line. So 3 CH3 is there, 1, 2, 3. So that is 1, 2. Okay, the one line is, that is CH3. ஒரு லைனுக்கு பேர் என்ன? CH3. So இங்க ஒரு CH3, இங்க ஒரு CH3. Again 1, 2, 3. So next one is 1 OH. So அப்படினா என்ன அர்த்தம்? So ஒவ்வொரு இதுலயும் ஒரு வந்து, so இதுல ஒரு CH3 இருக்குன்னு அர்த்தம், இதுல ஒரு CH2, அடுத்தது இதுல ஒரு CH2, then OH. So this is the meaning for this bond line structure. So this is the bond line structure. So next one is, what is mean by next one? 1,3-butadiene, C4H8. Okay, C4H8, C4H6, 1,3 butadiene. Okay, 1 C4. How to? So first you draw 4 carbon. Okay, so then 1,3, that is the first position, 1 double bond, 1,3 again double bond. Okay, so that is the 2 double bond is there. Remaining you fill the hydrogen. Here 1 hydrogen, here 1 hydrogen. So here each carbon satisfy 4 valency, 1, 2, 3, 4. So here 1, 2, 3, 4. Okay, here 1, 2, 3, 4. So here 2, 3, 4. This is the structure 1,3-butadiene. So how to write this condensed structure? That is CH2 double bond CH, then CH double bond CH2. Okay, this is the condensed structure. What is bond line structure? So here how to draw this structure? So this is 1, this is 2, then 3, then 4. So here that is 1 double bond, again another double bond. Okay, so this is the condensed structure. This is the bond line structure. This is 1 CH2. What is the meaning for that one? Here 1 CH2, here 1 CH, here 1 CH, then CH2. Okay, so this is the meaning for this compound. Okay, so next one is tertiary butyl chloride. So next one is tertiary butyl chloride. Tertiary butyl chloride. What is the compound name? That is molecular formula C4H9Cl. Okay, C4 means, so that is 4 carbon, 1, 2, 3, 4. Tertiary butyl. So again 1 chlorine. Okay, tertiary butyl. So remaining, how to fill that one? So each carbon containing 3 hydrogens. So tertiary butyl. So that is here 1 hydrogen, this is another hydrogen, here another hydrogen. This is also containing 1 carbon containing hydrogen, this is hydrogen, this is hydrogen. Here also another carbon, hydrogen, then hydrogen. Okay, so this is 2 compound is not coming, that is Cl. Okay, only 4 carbon, 1, 2, 3, 4, that is tertiary butyl chloride. Tertiary butyl chloride. How to draw this condensed structure? That is CH3, 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 Cl. Okay, so what is the bond line structure? So that is only this is bond line structure. Here one CH3, here one CH3, here one CH3, here one C. Okay, this is one C, so remaining Cl. Okay, that is tertiary butyl chloride. Okay, so this is the another structure. So next structure 1,3 dimethyl cyclopentane. 1,3 dimethyl cyclopentane. Okay, so what is the molecular formula? C7H16, right? Okay, so how to draw the structure? So here cyclopentane. Cyclopentane means that is 5 carbon. 1, 2, 3, 4, 5. Okay, this is the 5 carbon. 1,3 dimethyl. So that is here one methyl group. That is CH3. That is one methyl group. Here also one methyl group. H. Okay, that is one methyl group, dimethyl. So remaining each carbon, this is 1, 2 bond is there, again one hydrogen, here one hydrogen, here 2 hydrogen, here another bond. Okay, so here 1, 2, 3, here one hydrogen, here 1, 2, so one hydrogen, one hydrogen. So this is the dash line structure. What is the condensed structure? You coming that, so that is CH2, CH3, then CH2, then CH, here one CH is there, so one H, CH, then here one CH2, then CH, then CH3. Okay, so this is condensed structure. What is the bond line structure? So remaining only one pentyl ring. So here one dimethyl, 1,3 dimethyl cyclopentane. Okay, so this is the model of this. This is the organic structure. This is the Lewis structure, dash line structure, condensed structure. This is the bond line structure. Okay, so this is the another one. So next one is what is meant by molecular model. Molecular model. What is the molecular model? What is the molecular model? That is frame model, ball and stick model, space filling model. So what is the molecular model? So here you see the diagram. So here this is the framework model, ball and stick model. So that is the space filling model. So this is the model. This is the methane model. So what is the formula? That is CH. So here that is one side. So here another one is. Okay, so this is the ball and stick model. So here that is one bond, one carbon. So here remaining 3 carbon. So this is the ball and stick model. Okay, so this is the ball and stick model. So here that is the 4 carbon. So middle one carbon is there, remaining 4 hydrogen is there. Okay, so this is the methane ball and stick model. Okay, so this is the another one. Okay, so next one molecular model. So next one molecular model. So that is a 3-dimensional representation of the organic model. That's why I'm showing that. So that is, this is the carbon. So this is the, what is this bond? That is bond towards the absorber. Bond towards the absorber. Towards the absorber. So next one is, this is bond away. So that is the back side of this carbon. In the 3-dimensional view, it is present in the bond away from the absorber. So that is the back side of this carbon. Bond away the absorber. This is the solid line. So this is solid wedge. What is the name of this one? This is wedge. What is the name of this one? That is solid wedge. Okay, this is solid wedge or heavy line. So the dotted line is called as, so that is dashed wedge. So what is the name of this one? That is dashed wedge. The line is named, the dotted line is represented is the dashed wedge. So this is called a solid wedge. So this is the solid wedge. This is the above the absorber, bond towards the absorber. This is bond away the absorber. That is the below the plane. So this is the above the plane. This is below the plane. So that is the normal line. Bonds of the plane of the paper. So this is the solid line. This is the bond, the bonds in the plane of the paper. Bonds in the plane of the paper. In the plane of the paper. Okay, so this is the three-dimensional view. So this is the this is the structural representation of this carbon. This is the three things. So first one is solid line. So the solid wedges, so that is called as bond towards the absorber, that is the above the plane. This is this one below the plane. This one is bonds in the plane of the paper. Okay, so next one is what is meant by Fisher projection formula. Fisher projection formula. Projection formula. What is meant by Fisher projection formula? So first one is, this is the representation of the three-dimensional structure in the two-dimensional view. So in this method, that is chiral carbon. What is meant by chiral carbon? So here I am writing one example. COOH, that is COH, H, again CHOH, COOH. Okay, so this is the one compound. What is this compound? Name is called as tartaric acid. What is the name of this compound? Is tartaric acid. Okay, how it is represented as? It is represented as COOH. Here OH, H, then HOH. Okay, here COOH. So this is the bond line structure, right? This is called as chiral carbon. What is meant by chiral carbon? So the carbon containing four different groups. So here COOH group, OH group, H group, again carbon group. So one carbon le four different carbon attach ஆயிருந்தா அதுக்கு பேர் வந்து என்னது chiral carbon, chiral center, chiral carbon or chiral center. Okay, that is the chiral atom lies in the plane of the paper. So this is the ஒரே carbonல four different group இருந்ததுனா அதுக்கு பேர் என்னது chiral carbon. So here that is two chiral center is there. Here one chiral center, here one chiral center. This is the tartaric acid. This also in this Fisher projection formula for the tartaric acid. How to draw this Fisher projection formula of this tartaric acid? This is the dotted line, right? So this is the dotted line. COOH, COOH. So here OH, H, here also here also OH, H. This is the Fisher projection formula of this tartaric acid. This is the one structure. So next one is another structure, Sahas projection formula. What is meant by Sahas projection formula? Sahas projection formula. What is meant by Sahas projection formula? It is the bond between the two carbon atom is the drawn diagonally and slightly elongated. The lower left hand carbon is considered lying towards the front. So again I am drawing this same compound. So here that is Cl H2N CH3, that is dotted line, again CH3, this is H. Okay, so this is one structure. So again this structure can written as likewise again the dotted line, OH, OH, H, CH3, H, CH3. Okay, so this is the Fisher projection indicated that is the spatial relationship between the ligands attached to the adjacent compound. So this is one carbon, this is another carbon, it is attached with the different compounds. So that is the Fisher projection formula. From this structure, each carbon one is behind the other carbon. So that is the Fisher projection formula is inadequately, that is the spatial relationship between these two carbon. So that is called as Sahas projection, that is clarify the relative location of this group. That is the another one. Next one is Newman projection formula. Newman projection formula. Newman projection formula. What is Newman projection formula? Again, it is the one and behind the other, so that a front carbon is seen. So that is, this is one structure. How to draw the structure? CHO, OH, H, HOH, then CH2OH. Okay, so this is the one compound. Again, it is the another compound. What is this compound name is called as? That is two carbon atoms lying behind the other carbon atom. So again, I am writing here that is the one carbon, right? So this is the one carbon. So this is the another carbon, right? This is the another carbon. Dotted line is the another carbon. H, OH. Then the dotted line, that is Ca, that is the back side of this compound. Again, another one is here, that is CHO, here OH, that is H. So this is the one circle is one carbon. So this is one carbon, this is another carbon. This one carbon containing CHO, OH. So that is the seen is, that is the another carbon. So one carbon is not seen, there is a one circle. The other carbon lying further from the I is represented the origin of the circle. That is CH bond in the front carbon or that is the circle. The CH, this is the one carbon bond. This is the another carbon bond. Back carbon, that is the circumference of this bond angle is 120 degree. Okay, so this is the structure. This is the molecule of the structure of the Newman projection formula. Okay, so this is the another one. Next one is isomerism in the organic compound. Okay, next topic is isomerism in organic compound. First, we are going to see the what is mean by isomerism. So, isomerism, that is the compound containing same molecular formula but different structure. One or more compounds with the same molecular formula, but different structure. And the properties is also different. Okay, that is called as isomerism. What is mean by isomerism? The compound containing same molecular formula but different in the structure, that is called as isomerism. Okay, so in this isomerism, again it is classified two types: structural isomerism and the stereoisomerism. The structural isomerism, again it is classified chain isomerism, then this is one chain, then second one is position isomerism, the third one is functional isomerism, then metamers, then tautomers, and another one is ring chain. This is the type of structural isomers. And stereoisomers, again it is called as conformational and the configurational. The conformational, that is the configurational, that is geometrical isomerism, the optical isomerism. In this chapter we are going to briefly about all this isomerism. First one is constitutional isomerism. It is otherwise called as structural isomerism. First one is what is mean by chain isomerism. So I am writing here what is mean by chain isomerism. So what is isomerism? Same molecular formula but different structure. So that is what is meant by chain isomers. These isomers differ in the way of which the carbon atom are bonded, or the only different in the carbon chain. Same molecular formula but different in the nature of the carbon chain. Okay, so that is called as, so same molecular formula but differ in the carbon chain. So what is the meaning for that? Differ in the carbon chain. Okay, so this is called as chain isomerism. What is the meaning for that? I am writing one example, right? So that is N-pentane. So what is mean by N-pentane? So that is straight chain. Pent, what is the pent means? How many carbon? That is 5. Okay, I am writing here that is 5 carbon. So this is the 5 straight chain, right? So how to fill the hydrogen? One bond is there, 3, 1 to 2, here 1 to 2, here 2, here 1, that is 3. Okay, this is pentane, N-pentane. This is the one carbon chain. So what is meant by another chain? So here CH3, the same compound I am writing here, that is now the carbon chain containing 4 carbon chain. This is coming under substitutional group. What is the name of this compound? 1, 2, 3, 4, 2 methyl butane. but the same number of carbon, 5 carbon is there. I am writing the carbon chain. So this is the 5 carbon chain, this is the 4 carbon chain. This is the one of the difference. Again another one is the same compound we can write like this: CH3, 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 CH3. Okay. So this is called as neopentane. What is the name of this compound? Is neopentane, or how to write the IUPAC name? 1, 2, 3. So 2, 2 dimethyl propane. Okay, 2, 2 dimethyl propane. This is the another one. Okay, so this is the chain isomerism. So what is meant by chain isomerism? That is, the isomerism is very important. Same molecular formula but differ in the carbon chain. So molecular formula வந்து same இருக்கும், carbon chain வந்து different இருக்கும். இது வந்து 5 carbon chain, this is 4 carbon chain, this is only 3 carbon chain. So that is only the carbon chain will be differ. Okay, this is the another one. So next one is what is meant by position isomerism. What is meant by position isomerism? Next one is position isomerism. What is meant by position isomerism? The same molecular formula but the position of this double bond or functional group will be differ. So same molecular formula but differ in double bond or functional group position will be changed. Okay, so this is how to exhibit the example. I am writing one simple example. Okay, CH3 CH2 CH2OH. Okay, what is the compound name? That is propanol. Okay, this is 1 propanol, 1, 2, 3. So that is 1 propanol. So again I am writing the same compound, OH CH3. How to write? What is this compound name? 1, 2, 3. That is 2 propanol. 1 propanol, 2 propanol. So this is one example. This is simple example. 1 propanol, 2 propanol, 1 in your book. So that is the writing the double bond. So that is the changing the double bond. So that is pentene. So how to write the pentene? Another one example. This is one example. Another, this isomerism, you can write the 2 example. How it will one compound is changing the other compound. This is so we can write the 2 example, right? So another one is pentene. So CH3, C4 carbon, then CH2. So here 2H2, H2, that is H. So this is pent 1ene. Pent 1E, that is first position containing double bond. Again another one is CH3 CH2 CH double bond CH CH2, 1 2 3 4 5, that is 2 pentene. That is 1 2 3 4 5, that is pent 2E. Okay, so this is the another example. That is the double bond, it will present in the first position. Again the same double bond present in the second position. So that is the another example. So next one, this is called as position isomerism. So next one is functional isomerism. So what is meant by functional isomerism? One functional group is same molecular formula but change one functional group, change in the other functional group. Same molecular formula, different functional groups are said to be exhibit in the functional isomerism. Same molecular formula but different functional group. Okay, so what is how to write? So this is the CH3 CH2 CHO. What is the functional group here? This is aldehyde functional group, right? This is aldehyde functional group. What is the name of this compound? Root 3 carbon. What is the root word? Prop saturated ANAL, propanol. Okay, so this is propanol. Again the same compound I am writing here, that is C double bond O CH3. The same compound, C3 carbon is there, hydrogen 3 plus 2 5 6, 3 plus 6 6, hydrogen, that is oxygen, only one oxygen. So that is the same compound. What is the compound name is called as propanone. Propanone. So what is the functional group here? That is the keto functional group. That is aldehyde functional group is changed into keto functional group. That is called as functional isomerism. So what is meant by functional isomerism? Same molecular formula but differ in the functional group. That is one functional group change in the other functional group. That is called as functional group. So next one is what is meant by metamerism. Metamerism. What is meant by metamerism? That is the same molecular formula but different alkyl groups are attached to the either side of the functional group. So that is same molecular formula but differ in the attachment of alkyl group in the either side of the functional group. So what is the meaning for that? So what is the meaning for that? What is the meaning? Same molecular formula but differ in the attachment of the alkyl group in either side of this compound. So what is, I am writing one example. So how to write? C4H10O. Okay, what is the compound? So this is the ether functional group. How to write? That is C4. So this is 1 oxygen. Okay, C carbon. So 4 carbon is there. I am writing here. That is 4 carbon. This is 1. So 1 carbon means that is 3 hydrogens. So here 2. Here 2. That is CH3. What is this compound name? So what is the name of this? This is ether functional group, right? Methyl propyl ether. How to write? Methyl propyl ether. This is one functional group. Okay. So again the same compound. How to write? CH3 CH2O. Again another 2 carbon. CH2 CH3. So this is ethyl group. This is ethyl group. Diethyl. This is ether functional group. Diethyl ether. Okay, so I am writing the same compound C4H10. I am writing the two way or writing, that is the either attachment of the alkyl, same molecular formula but attachment of this is called as alkyl group. This is also called as alkyl group. Either side of this is the functional group. The attachment of the alkyl group is differ in the either side of the functional group. So another one example, C5H10O. Okay, what is the compound name? That is ketone functional group. CH3, CH2, C double bond O. Here the CH2, CH3. So here also ethyl group. This is also ethyl group. So diethyl ketone. What is the compound name? Diethyl ketone. So again this is also I am writing here 1 carbon. Here double bond. Here 2 carbon. Right? Here, that is the 5 carbon. Also remaining 3 carbon. 3 plus. So that is CH3. CH2, CH2, CH3. Okay. So here methyl propyl ketone. So methyl propyl ketone. Okay. This is the another one. So the same compound we can write like this. CH3, C double bond O. This also branch chain. CH3, CH, CH3. So this is isopropyl. Methyl isopropyl ether ketone. Methyl isopropyl ketone. Okay, this is called as metamerism. Okay, this is called as metamerism. Next one is what is meant by tautomerism. So here what is meant by tautomerism? So here the single compound exists in two interconvertible structure that differ markedly in the position, at least one atom of nucleus. So that is single compound exist in two readily interconvertible structure. convertible structure. So give one example. There are several types of tautomerism. So here that is we are going to learn that is triad and the triad system. So what is meant by dyad system? What is meant by dyad system? So that is hydrogen C triple bond N, that is hydrogen cyanide, that is interconvertible one, hydrogen nitrogen, so that is carbon, hydrogen isocyanate. So here Cn, it is converted into Nc, that is hydrogen isocyanate, hydrogen isocyanate, that is one compound is changed into another compound, that is nitrogen cyanide interconverted into isocyanate. Okay, this is the another one. Next one is what is meant by triad system. What is meant by triad system? So that is here, that is the hydrogen atom oscillate between the three polyvalent atoms. So here that is one hydrogen atom having the oscillate of this two remaining compounds. So how it will be explained? That is hydrogen CH2 C double bond OH. Okay. So what is this hydrogen? So the CH3 here CH. So here this hydrogen it is coming. This is also here CHO aldehyde. So that is keto group. So it is interconvertible one. So here CH2 C double bond CH OH. So this hydrogen is an interconvertible. So in the hydrogen ingeyum varla. இந்த பாண்ட் வந்து இங்கேயும் வரலாம், அதே மாதிரி இங்கேயும். ஸோ இந்த காம்பவுண்ட் இங்கே வந்தால் CH2, இங்கே CHOH, இப்படியும் நம்ம இந்த பாண்டை எழுதிக்கலாம். ஸோ ட்ரையாட் சிஸ்டம், இந்த ஹைட்ரஜன் வந்து ரெண்டு காம்பவுண்டுக்கும் பொதுவாக இருக்கும், அதுக்கு பேர் தான் வந்து ட்ரையாட் சிஸ்டம். திஸ் இஸ் கால்ட் அஸ் அசிட்டால்டிகைட். திஸ் இஸ் த டைப் ஆஃப் தி tautomerism. Next one is what is mean by ring chain isomerism. Ring chain isomerism. What is meant by ring chain isomerism? The compounds having the molecular formula but differ in terms of bonding in the carbon atom, that is the cyclic structure. So example CH3C CH double bond CH2. So this is propene. This is called as cyclopropene. So how to write? That is CH2 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 CH2, that is the interconvertible one. This is called as cyclopropene. So that is cyclopropane. So propene is, this is called as propene, is converted into cyclopropane. Okay, another one is cyclobutane. So CH2, that is the 4 carbon. So this is the cyclic structure. That is 4 carbon cyclobutane. So how it will be changed? So that is CH2, CH, then again CH3. Okay, so this is methyl cyclopropane. Okay, so this is the another one. So this is called as, this is the ring chain isomerism. Okay, this is the ring chain isomerism. This is the another example. Next one is what is meant by stereoisomerism. Stereoisomerism already called as geometrical isomerism. Stereoisomerism, it is called as geometrical isomerism. Again it is called as cis-trans isomerism. Geometrical is again geometrical isomerism. Again it is called as cis and trans. Okay, so how to name? Cis means same. Similar groups are present in the same site. Same site, similar group present. Similar group present with the carbon double bond carbon. Okay, so that is same site, similar group present with the carbon double bond carbon. What is meant by trans? Similar group present in the similar groups present in the opposite side. Present in the opposite side. Okay, opposite side with the carbon, opposite side, that is carbon double bond carbon. Say for example butene. So how to write? CH3 C double bond C CH3, here H. What is the compound name? That is CH. HH ஒரே sideல இருக்கு, H3 ஒரே sideல இருக்கு. That is called as cis. Cis 2-butene. How to name? 1, 2, 3, 4. Butene. Cis but 2E. Okay, so this is butene. 6,2-butene. So the same compound, how to write? Again, CH3, C double bond, C, here another CH3, here one H, here one H. The similar group are present in the opposite side. That is called as trans 2-butene. Okay, so this is called as cis and trans isomerism. So this is the cis isomers. Cis are converted in trans isomers only if the either isomer heated to a high temperature. So observe slide. So what is the cis isomer is converted into trans isomer when we are heating. So when we are heating means they absorb the some amount of energy. It is converted into another become upon the cooling, the reformation of the again it will be changed into the same position. That is the cis isomer and the trans isomer. Another one is important question. Why trans isomers? Which one is more stable? Which cis isomer or trans isomer? So that is the cis isomers or trans isomers are more stable due to the steric hindrance. Because so this is the trans isomer. The one important question. Trans isomer, the opposite sides are attract each other. So that is the cis isomers are the same side mean that is repulsion will be occur. The bulky groups are same side double bond. The repulsion of the group make the cis isomer. This one is less stable. Less stable. This one is more stable. This is one important question. Why trans isomers are more stable? Because of this cis isomers are less stable than the trans, which is the groups are on the this is opposite side. That is due to the steric hindrance repulsion of this group makes cis isomers are less stable. The trans isomers are more stable. Okay, so this is the isomerism, geometrical isomerism. This is remaining continuation for this isomerism. We see the next video. Okay, thank you children.